Just another philosophical point that's not really true, but has a lot of truth to it. That research mathematics is essentially nothing more than a good argument, okay? And a problem I'm having here in saying all this articulately is that there's nobody here to argue with. I'm arguing with myself. And it's not always something that's best done in isolation, although Andrew Wiles, if that's how you pronounce it, got proof Fermat's last theorem. He spent a lot of time just arguing with himself, okay? Came up with something extraordinarily profound. And I don't pretend to understand that or most of research mathematics. I did it at a very low level in graduate school. But the idea of a good argument I've seen with students and I've seen in my own graduate experience, where we would congregate after a class, a high-level class, and just bat our details around. Now, there was one guy who happened to be an undergraduate who's just absolutely brilliant, and it was fun to toss out a good idea and watch him instantly see all the implications of that idea, all the implications that might take me years to work out, and he'd see them in an instant. So he could take a good idea and run with it. And the rest of us could take good ideas and plot about with them and so forth. The point is, if there's somebody to argue with and somebody says, no, that's not right, and I think, oh, you're right, that's not right, I would see very quickly how to fix it because of something very much like social pressure, which is sort of missing right now since we're all battened down due to the coronavirus. I'm not blaming the coronavirus for any inarticulateness or errors I make. I can blame age and relative stupidity. But this is the kind of thing, if you're trying to develop this proof, that would be best developed in dialogue, maybe between a professor and a graduate student, although this proof is totally trivial as a level of research mathematics, okay? But it still illustrates a lot of what goes on. And a lot of research mathematics is, of course, done by correspondence, by teams, and so forth, where everybody is pushing everybody forward, and everybody's not just trying to pull themselves up by their own bootstraps, okay? So just one reason I'm doing this is for an exceptional student who wants to be a research mathematician, and trying to illustrate some of the aspects of how you develop a challenging proof. And this proof seemed like it was going to be just totally obvious. It probably is, and when I get to the end, I'll see how it was. And as I said, then I could deliver a lecture pretending I knew it all along. And it was all as obvious to me as anything, which is what you see in a lot of lectures. You don't see that when you're struggling toward the proof of something that is challenging and unknown, okay? It develops and fits and starts, and I'm having a lot of those.